Okay, I share. Oh, you share your side, right?
Yeah.
Okay, I can see now. Yes. Oh, that is a revolution of the x-axis of the volume, right? The volume. Oh, that is simple. They just you just apply the formula. You just slice this hypothetical 3D volume into slices. So you have a notion about x-axis. Can you just assume this is the case? We'll see if that is the case. Share screen. If that is the case, I know you have a notion. So basically you have the so this is a typical question. So for example, you have x, y axis, and they give the function, right? They give you the function. For example, they give you say just case this is a you see the can we do this function? How can we write this function? Can we any function? Can you see any function? For example, it's exponential function, right? It's an exponential function. So what they're going to do is want to ask you to rotate this. Can you see? They give you a certain range, right? They give you you go to a certain range A and B, right? That is the height of this this is a kind of cylinder, but it's not a cylinder. It's so this is Y, this is X, you see? And what you're going to do with this point P, and they want to rotate that. You have imagined this is a 3D diagram, you see? You can rotate it as a circle, can you see? So that all of this became a 3D volume, can you see?
Yeah.
That's right. So this is, remember, this is a circle, can you see? So how do we find the area of a circle? The area of this area, how do we find, what is the formula for this area? Is like cross section when we calculate the flux, you see magnetic flux. So this area should equal to, can you see the area must equal to pi r squared. Do you agree? And because so r could be anywhere, because this is a circle. In the special case, it's also equal to pi y squared. Can you see that? So that is how this step one is to work out. This is a function is called yx. Okay, it could be exponential of any function. Is curve. So in this way, we can calculate the area of any cross section. You see?
Yeah.
You can call this cross section. Cross section of this volume. Okay, it's cross section cross. Not E but S section. Okay. If know the area, how can we work out the value? Then we can keep this tiny thickness. Can you see? Is this exaggerated now? Okay. So the thickness of this one is so small that we can actually represent it by dx. Can you see? So this is area, but for the volume, can we use the dV of this cylinder? Can you see? This is a cylinder. Can you? Very tiny. It's called. This is a typical cylinder now. It's a cylinder. Can you see that's a cylinder? Can you recognize this cylinder? So cylinder is such. This is a circle. Can you see? And this height it normally is higher, but in our case, we are interested to calculate this volume. So this thickness is exactly equal to dx, very small. Of course, you can see if this dx is so small and these two circles are should be identical. Do you agree? So therefore, this called dv. So the dv can be written as the a multiplied dx. Can you see that?
Yeah.
Or if you continue, that should be can be subtract that will be equal to d pi y squared multiply dx. Can you see?
Mm-hmm.
So that will give you this tiny slice. Can you see? I can cut this slice anywhere. Can you see in between A and B? Can you see? This I cut
Yeah.
the you know, in the supermarket, if you buy a loaf of the uncut bread, okay, you can ask them to cut that. They can ask them slices for you. Do you know this service?
Yeah.
Yeah. So that's how we cut this in that way. So we can argue that the total volume of this object due to that rotating about x-axis, can you see, due to this rotation about axis, then the total volume. So once we use the dv, and so once we know this formula, then we can argue that the total area will be equal to dv from A to B. That is the formula. Is that simple? If yes, continue.
Yeah.
If just continue, you can put the pi outside. Can you put the pi outside? That is y squared and dx. X from, in our case, from A to B. Okay, so that is the formula. You see, you can use this formula to solve any question. Okay.
Yeah.
You want to try? Do you want to take example?
What if they tell us to find the area between two different formulas?
Say it again. Find the area between two formula.
Yeah.
Yeah, there's another question. So let's just return to yourself. Are you talking about another question? At the moment, I will tell you the formula for work out the volume. Are you going to calculate the area? Did you see?
Like the volume between two different things. It's like a donut
yeah.
shape.
Oh, you got two volume. You got two volumes. They cut each other, right? Okay, that's good. That's good idea. So that's this is can we do the exercise first, right? To make sure you know this basic formula, because the question you're asking is just the second. This is the first type. Okay, I give you the question. You can find the question. Can we just give the question if say if y is equal to x squared and minus 2x. So what is the volume between x? Let's just give you a question. Between x equal to 1 and 3. What is volume? Can you try?
Yeah.
You have to learn this formula first. The formula you're asking is just derivative formula from this basic form. Yes, that's a formula. Hang on. You forget about the square here.
Oh, right.
Yes, that's right. Don't jump. Okay. If you don't use the formula, how can you start from how can you solve the more complicated one?
So do we first have to expand it like this?
That's right. You have used the quadratic expanded. Yes. Yep, you're right. Yeah. Yep. Yeah, I think you can do that. The number is trivial. Okay, it's fine.
Yeah.
We can stop here. I'm sure you can work it out by yourself with calculator if necessary. So let's go to the second type of question. So this go to next page. Okay, now the question asking that what would happen if that volume is determined by two curves? Is that right? You have two curves, so then that can be done. Let's just go to can I draw the diagram? Can you see? Can I draw a diagram here? So we got the y-axis, this x-axis. All right. Now, if that is involved two curve, can we just hypothetically assume that is so from? Can we use what call this stepwise function? What do you call that? What call that a function which so function equal to say function equal to x squared. Okay, when x is between one and two, what is this? What's the name of this function? Stepwise function, or what do you call it?
Piecewise function.
Piecewise function. Okay. So x equal to, we just use a piecewise function. So that is x, so this is 2. That is 4. So that is x equal to 2 and 4. Okay. And 4. And after that, I will just start from the simple one. Okay, that's 2. Can we draw this diagram? So one is a parabola. Can you see? Right, it's a parabola. After that, they become constant. You agree?
Yeah.
Are you talking about this shape or more complicated one? This is a piecewise, right? Piecewise function. So this is 0, this is 2, and this is 4. Can you work out the volume due to this rotation? You see, revolutionary, this revolution. And maybe use this diagram, we use a circle, looks better. It's a circle, yeah, okay. Can you draw the circle here? And draw the circle here, right?
Yeah.
So that's the same. So that's just a sum of these two, right? You just write the formula, that's all. Can you just write the formula for this? Can you just write the formula for this one? That's all. That's good. Okay. Let's go more challenging one. So if you have this time is determined two curve. Can you see? Maybe you can give me a question from your textbook made by two curve. I stop here. Can you give me an example which is determined by two functions? You have to cut something, right? For example, you have to drill the hole inside. That is one. 15, right? Yeah, it's similar. It's similar, right? You only need to find the intersection to determine where is the border, boundary condition, right? So if you just here, what you need to do, you just this is a calculated area or not, a volume? Rotating the shade area. Oh, you have rotate. I understand.
Yeah, and the volume. So it's a
Yeah,
volume.
and the volume. Yeah, so basically I'm looking for volume. So in this case, I can't annotate. I know now. This is similar to our second example, all right? It's similar, except it's this piecewise function is not is more complicated. Okay, so basically, if you have, in your case, we can draw two functions here. So one is this var, this y, this x, and they got two curves here. Now one is curved like this. Can you see? Like that. Another is a curve like this. Can you see? That's hypothetical function, all right?
Yeah.
We just call this, we generate this formula, all right? So basically, this is a constraint. This is where this is A. Can you see? And this is a B, and this be our C. Can you see that?
Yeah.
Our C. That's give you the same. So if you call this is if this function is F, you see, if it's Fx, and another is green one is a Gx. Okay. If you rotate this shade area, we shade this one, you see. Okay, you tell me how to, can you write a formula for this volume if we rotate this area by about x-axis? Can you write a formula for this volume?
Um.
So this is y, yeah. This is x. You have to rotate that about x-axis. Yep. Pi. Forget the pi.
Yeah. Pi here.
Ah, you have to, if you share the pi, you have this bracket. Or you share that. You share the pi you have with bracket. Okay, it's fine. Okay. It's probably a little bit more. I can imagine. I can make another one, which probably more challenging. That is, if you just imagine this question 3 or 4, whatever. Question 4, yes. Question 4. This time I give you this shape. You see, and this time I will give you a challenging question. This time we got this. We got the function which is a constant. Can you see? This coverage. Okay. So it's a constant here. Another function is like this. Can you see? So I call this function. This is fx. Well, of course, this is simple. It's just a constant function, right? I make it changing. I both make both are circle, a curve, right? So if we got to the purple one, then we got to the orange color one. Okay. So this time I just make it a function. So this function is fx. I use a particular form now. So this fx is equal to phi e and x divided by 10. All right. I give some numbers to practice. And this gx is exponential as well. That is a 4e negative. You see, x divided by 20. Okay. Now, what I'm going to do, I'm asking you to work out this the volume. Imagine there's a rotation. Can you see? This is 1, and this is 3. Okay. Now the shaded area is slightly different. Be careful. This time, this is the shaded area. Can you see? Didn't touch the x-axis. Can you see? So you can imagine there's a hole in this case, right?
Yeah.
There is a hole in this case. So how can we work out this volume if we let it rotate about x-axis? Can you try? So that's let it rotate. So let it rotate. It's just like the engine, okay? The jet plane engine, right? Take. Oh, good idea. Take difference.
Mm,
That's right. Yeah, you just make a two volume and subtract them. Good idea.
mhm.
Can we simplify this a little bit before we go integral? That's right. It's
Mm.
you could be a math teacher. Your writing is so good. Actually, some teacher writing is terrible, isn't it?
Um, uh,
So you divide by 5, you have multiply 5, right?
mhm.
Yeah, good way to. I like my question. They should be selected in the textbook.
Um, what is 25 times 5?
Yes. 75, right? Oh, not more than 75. 75 is 3 times. 100 or something.
125.
125, yeah, 125. Yep, as simple as that.
And I think from there, it's just.
Yeah, just substitute the number. Yes.
Mhm.
No problem. So you have no trouble with that. Can we go back to your textbook to see if you have any other question to discuss? Volume of Sony's revolution. Ah, this is another issue. The sphere, right? There is a
Mhm.
cylinder. They're in the cylinder into the sphere. The cylinder cut is a sphere. Yeah, that's a challenging question. So what we can do? Can we just find the two same strategy? Can we work out these two volume, right?
Yeah.
Separately. Let's just go to whiteboard to how to solve this one. I think what doesn't matter. The number is important. We just work out the formula first.
Mhm.
Go to next page. All right. A sphere. Wow, this is sphere. How to imagine the sphere?
Um, this we're trying to find the area, which is 2 pi r, right?
Mm-hmm. Well, you see, this is a challenge. This is a challenge question. Question 5, right? Because
Mhm.
yeah, you have to consider several issues. We are not dealing with rotational, right?
Mhm.
It's still belong rotational, but we can simplify that. Basically, we got a sphere. This time got a sphere, right? And if you just look at the cross section, you are going to build the this is cross section. Can you see? You can draw the hole. You can draw the hole into the sphere. You decide where do you go to your X and Y. Can we put the origin in the middle? Do you agree? It's a good idea.
Yeah.
So it's a good idea to put it into the middle. And so in this case, do we have to use integration? We don't have to use integration. Do we have to use integration?
I don't think so.
Okay, try it. If you have to, yes. Do we what do we know the size? Do we know the radius of the radius? The cylinder. Do we know the radius or both? We need two. One is radius
give us
of.
a diagram that's.
We need to find two radius. One is the radius of the sphere. Another is radius of this cylinder. You agree? It is R1 and R2. You agree? Yeah, you can draw another one if you wish. That is not cross section. You look into the cylinder, right? Look in parallel to the cylinder. That's what we're going to see. We're going to see. By the way, how do we work out this what volume of the sphere by integration? That is if you do want to use integration method.
2 pi x, that's the volume of the sphere.
Yeah, how do we write that? How to write that formula? Two pi x. 2 pi. What is 2 pi x? Oh, which is your x? This is your time. This is your drawing, right?
Yeah.
So we have to make sure we're okay.
The area of this.
Oh, one is 3. One is I thought now. One is 3. Another is 5.
They want us to figure out this area.
Yes. Then you rotate. How do you rotate? Are you sure? Remember, this is a sphere. You're looking from the cylinder. Can you see my perspective is different from yours? Can you see? If my perspective differ from yours, so you in this case, you are not in there. Say another x-axis, right? If this is y, this is not x. Did you call this x? If you call this x, I wouldn't call this x anymore. I call it z. Can you call z? Do you call it x? In this case?
Yeah.
Okay.
Oh, is this on a 3D plane?
Yes, you have imagined how do we figure out this one. But it's difficult because you are dealing with you look at see in this case you look at this diagram in this way. Can you see? So you look at here one. So you in this case you only see the circle, right? You only see the circle. That's inner circle. However, of course, you can consider this also due to rotation. You generate this this volume of the sphere. Yes, you can still apply this formula here.
So we have to figure out this.
Yeah.
And then use that to figure out the volume of the sphere.
Well, up to you. You can try. Yeah, you can either work out the you have to work out the two volume. Do you remember? You remember the strategy is to work out the two volume and find their difference. But how can we do that? Which diagram shall we use? Yours or mine? So this is figure 1 and figure 2. Which one? Which figure shall we use? When you have make a decision.
Yours.
Okay. If you use mine, can we call this x instead? All right. This is something is I would call it z. So if we decide to use figure 1, can we use our knowledge to work out this difference of two shape, two volume rather? So you rotate that can easily introduce a rotation about x-axis. Do you agree?
Mm-hmm.
So we still can confine our discussing here. So can you try? This crossing area, this crossing, I use different color.
I'm not sure how to do this.
Well, just think about what we have just done here. This question. How did we do this? Same question.
Mm-hmm.
Same question.
I just don't know how to get the function.
Function for the blue one, right? The blue one. Blue one is a function. This is a circle. Do you know the circle equation? Equation for circle.
The circumference is 2 pi r.
Can I write down here? If that's the center at the center, that's right. Can I just write down? So first you need to know the equation for the circle. Okay, equation for a circle. How to do that? Circle. Can you see for the circle you just use r? Can you see? So
yeah.
R squared equal to x and y. Can you see this coordinates x and y? Do you agree? So r, x, and y must satisfy this equation. Okay, in our case, can we call R1 is a circle, right? A sphere, that is a sphere. But we're talking about the circle associated with the sphere. That is formula. So from here, we should be able to solve this y. If we just simplify the issue, just focus on this 1/4. I give you a clue, right? If I just focus on 1/4, then the question will become the difference between these two. Can you see? Can you see highlighted, right? That's returned to our previous question. Can you see? Provided you know this formula. Can you see? We know this formula now. Can you see? Once we know the equation of a circle, we can solve the y. What is y? How can we solve y? Yeah. Twice is a square root. We can, because in this part, this y is larger than 0, so we can pick up the positive one. Go on. We're looking for y. What is y? Yeah, square root. We can pick up -1 if we just confine to this quarter. Can you see?
Yeah.
In other words, our final result must be multiplied by the 4. Okay. All right, it's your turn.
What is this x value?
Yeah, as I said, do you agree? We just integrate just a quarter, so x value will be from 0 to this r2. Can you see? R2 is 5 from 0. Can you see?
Yeah.
So the range of integration will be from 0 to 5. That is a sphere. That is sphere, right? The volume of a sphere. We need to cut off the another cylinder. What can we do? Are you sure? Double check that. Are you sure this is another sphere? Are we dealing with two spheres? If we're dealing with two spheres, that's fine. But this we are not dealing with two spheres. So this is a formula. This is for the two sphere, okay? For two, not for that in our case, for two sphere, can you see? So you cut is one. Okay.
So B.
And also it's not right. This is right, not right. You have to stick with that idea that this volume is generated by rotation about x-axis, all right? Without this assumption, we cannot build the formula.
If R1 equals 3.
What is y in this case for the cylinder? What is y? In cylinder, can anywhere, what is y?
Minus x squared.
No, no. Can you see this is y? Can you see this is y? Can you see? And this y is always equal to 3. Do you agree?
Yeah, so it's 3, 0.
3, 0. No, return. You have to record the formula of rotating. Can you see? The volume. You have to rotate the volume is always equal to pi and a b y squared. So you have to determine what is y. What is y? Oh, yes, that's right. I agree. Yeah, you are right now. So that's correct. Let's go. Oh, duckies. We can get rid of this bracket, right? The square root now. It's good. I'll put a bracket here still. Wow, you get it. Yeah.
Yeah.
So this is a little bit challenging, right? You can easily got a two sphere. If you got this correct, if you are dealing with two sphere and this one must be something else. Can you see? If for the two spheres, that should be 3, not 5. Can you see? This is correct for the two sphere. Can you see? Can you imagine the two sphere?
Yeah.
The inner one and outer one. Can you see? So that is for two sphere, provided you use this 3. Okay. Wow, there's no challenging question for you. Can you go back to your textbook? When will be that external exam?
It will be
October?
sometime November.
November. Oh, no, yeah. Yeah, we got plenty of time. Yes, we solved the question 21. Good. Determine the volume and remaining volume. We have done that. We just have done that. Yes.
Yeah. What about question 22?
Okay. You can try. The curve is given by equation. It's circle, right? It's a circle. It is circle. It's cut by a straight line gradient. Okay. The curve and the straight line have the same y-intercept. Calculate the volume. Can you draw the diagram here based on this idea? Obviously, this is another circle. Do you agree? So, or perhaps you can go to whiteboard.
Yeah.
Okay. So this time, how many questions? Question 6 now. This time, question 6. We are dealing with a circle, right? Y equal to square root. Can you tell me the number? What is the number x squared?
4 minus 3x squared.
4 minus 3x squared, right? Is this one?
Yeah.
Okay.
And then we
And
also
another,
have...
you got y equal to straight line, right? Can you go, what is a, did they give you a function? We will decide. We will decide. We'll decide. Okay, we will decide. First derivative, so that is a equal to -1. Okay. What is intersection? Did they say cutoff at any condition given?
It says that the curve and the straight line have the same y-intercept.
Oh, this time the same intercept direction. That's good. So basically, we can imagine. Can we just rewrite this equation? So what is in this case, they got a factor here. So when x, what is x equal to 0? Is 2, right? So this y should be 2, isn't it? This is 2. This is 1, 2, and this x. And that give us a clue that intersect that at so basically that allowed us when y equal to 2, right? And x equal to 0. So that is our b, isn't it?
Yeah.
So then eventually we build it in this way. We build this equation now. Y is negative x plus 2, right? Okay, done it. Can you draw the graph of these two on this diagram? Just sketch. You don't have to be accurate. Yeah, it's not this is ellipse, not a circle. This is ellipse. Good. So this is y. So this or you can call this g. All right, just makes different. This is g. This is yx. Okay.
Yeah.
How can we find this? What is the y? Can we work out y intercept x? Can we work the x intercept as well? Or you can try. Oh, it's 2. Wow, it's 2. That's easy. Oh, that is 2. So that's this sketch is very accurate now. Can you see? All right. So what is another intersection for y? When x equal to what is y? What is x intercept for another one for the y? So for the y, this is for the g. Oh, you solved x. Good. Root 3 by 2. Is larger than 1 or smaller than 1?
Smaller.
Ah, smaller than 1. So x should be, so
oh, actually, it would be larger, wouldn't it?
Larger than 1 because that is it, but smaller than 2, right? So you have to redraw this diagram because the curve is actually intercept of the curve is less than the intercept of the straight line. 1 point something. Can you work out that? 2 divided by root 3? About 1 point something, 1.5, 1.3, 1.1, 1.1 or 1.2. 1 divided by 1.7. 1 divided by 0.7. Oh, it's half. It's very small. It's half, right? Or 2 divided by 7. Yeah, 2 divided by 1.7. 1.7, yeah, 1.17, right?
Yeah.
1.17, is it? So it's very close to 1, isn't it? That's right. Yeah, that's right. So be careful. So this time. So that is area. Can we highlight this area? Yeah. So once you know the diagram, it's easier to build equation. This case, this time we need to find another thing. Where is the intercept? Do we know? Do we know this intercept here?
Negative x plus 2 equals.
What? It's 4. Did you square on both sides?
Yeah.
You missed something.
Oh.
Did you?
Mm-hmm.
Because 2 take x squared is equal to 3 term, right?
Mm-hmm.
Equal to 4 take 4x and plus x squared. Can you see?
Mm-hmm.
You miss out.
Right.
You miss out this one. So this is not right. This is not right. Try it again. Try again, please. You still use a Frischmann's rule, Frischmann's stream. The quadratic is looks like 4 cancelled, right? 4 cancelled. Positive 4 cancelled.
Yeah. So it's
So how many solution for x?
2.
Yeah. Obviously, x is not equal to 0, right? Oh, x is 0 is all solution, but we need to find another 2 equal to another x value.
Mm-hmm.
So what is another x? X is to 1, right? Another is x equal to 1.
Equals.
Oh, well, how interesting. So if I refine your drawing, so this actually intersect is exactly here, right? Intersect is at 1. Can we redraw your diagram? So the diagram should be like this. You got intersect at 1. Oh, they have intersect at 1, and then have the intersect is 1.1. Can you see? 1.1 something. So this is the intersection. You see, this is the intersection of these two curves. All right. Can you see that? Can you see that? So basically, this is a straight line. Yeah, straight line. Okay. Can you formulate this equation now?
We'd also have to do this part, right? We'd have to
Which part?
calculate this one.
Do you think so?
If it's in a revolution, it would have that, right?
Well, this is two objects, right? You have to make it very realistic. If that is how can we make that? We cannot make that material, because you see we have the if you have two function, can we just we can only pick a one. Can I answer your question this way? Now, if you have the request, some people want ask you to make some volume or some shape, right? This says the shape is first is like this is internal, right? And this is external, okay? And somehow I need to larger. Let's do it make it larger. So this is a straight line. Somehow this function, another function, the curve function is looks like this. Curve function is go like this. Can you see? Do you understand? Make
Yeah.
this very close to our case. Another function looks like this. Well, exaggerate that a little bit. Okay. let's make this. Okay, that's much better. Okay. So in this case, do we have to, the question is, do we have to consider after we cut, this is 1, can you see?
Mm-hmm.
The question is, do we have to consider this area, can you see?
Yeah.
The answer is not, is no. Because these two volumes cannot be joined by this tiny, physically, by this tiny, tiny part, can you see? It's unstable.
Yeah.
And also you waste your material, can you see? So because what we're going to do after that, we have make a decision that we will stop here over this intersection, can you see? Can you write a formula for this?
So V equal.
Yeah, 0 to 1. So after you finish. No, we don't have second part. Do we have second part? We don't. I don't think so. You see, you have decided where when you stop here. We have to stop this rotation. Can you see? Imagine this is you can check your answer if you're not certain. Basically, in my opinion, this is you see after you rotate that one, can you see? And rotate that one, we have been already making a product, can you see?
Yeah.
This is complete product, unless you will make something else, but that which is not the point. Nobody would just build in this hole by this without this. There's no physical strings to connect these two parts. Do you agree?
Yeah.
So I suggest you stick with this one. In this case, just stick with this one. That's all. Okay.
No, don't we have to do this to figure out the area here?
No.
We have to get rid of this.
Oh, that's right. That's another thing you have to. Yeah, that's right. That's subtract this area. Yeah, you are right.
Yeah.
So that is y. Can you see? These are sorry. In our case, is a g. Do you agree? I agree. That is the case. Yeah. But don't forget about this area. This is beyond the design.
Yeah.
Yeah. Yeah. Yeah, that would already use a bracket here. Just indicate this is a polynomial. Yeah, I think you'll be fine. You'll be fine for this type of question.
Yeah.
And I think I'm sure, right? All right, can we stop here now, I think? All right.
Yeah. Okay.
Let's stop here. I'll see you next time.
I'll see you on Friday.
Friday, okay.